Hi guys, so now let's divide some rational expressions, which is going to be almost identical to multiplying with one extra step. That's pretty quick and easy. Okay, so when you're dividing rational expressions, your steps are going to look almost identical to multiplying rational expressions, only there's one other thing you have to do first. So before you factor the numerator and the denominator and start canceling out factors of 1, you're going to change the division problem to a multiplication problem. And how are you going to do that? Well, you change the division sign to a multiplication sign, and you take your second rational expression and flip it. This is called the reciprocal. When you have a fraction, like, for example, 3/8. The reciprocal of 3/8 is 8/3. You literally just take what's in the numerator and put it in the denominator, and take what's in the denominator and put it in the numerator. You flip it, okay? You swap it. So you're writing the reciprocal of the second rational expression by swapping the numerator and the denominator. Once you've done that, you've changed it to a multiplication problem and flipped your second expression. Then you factor the numerator and denominator of both expressions and cancel. So it's just like multiplying with that first extra step. And here's a quick example you can look at. I'm not going to go into the math of this one like I did in the multiplying video, but I do want you to notice that the first thing they did before they factored and canceled was they took the division sign and changed it to a multiplication sign. And then they literally swapped the numerator and denominator of the second expression. So what was in the denominator is now in the numerator, and what was in the numerator is now in the denominator. Okay? They changed it to that multiplication problem. If you want to look at the factoring and the canceling, you can pause and take a peek. Let's do our own example. So here's our example. It says divide and simplify. All right, you have two rational expressions. Again, I know that they're rational expressions because they look like fractions. Instead of all numbers, there's just polynomials in the numerators and denominators. So I'm going to look at my first rational expression. I have a over 2a plus 3. That's being divided by a cubed plus 6a squared minus 40a over 2a squared plus 23a plus 30. So the first thing I need to do is change this to a multiplication problem. And how do I do that? Well, I'm going to change my division sign to a multiplication sign. And I'm going to take my second rational expression and flip the numerator and denominator. I'm going to write that reciprocal. So let's take a look at that. All right, I put it in colors just so you guys could see. Nothing at all happened to the first rational expression. That one stayed the same. All right. I then changed my division sign to a multiplication sign. And I took my numerator from, oops, that's supposed to be red. I took the numerator from my first rational expression, and then I just put it in the, from my second rational expression, and I put it in the denominator. And I took the denominator, and I put it in the numerator. So I literally just flipped that numerator and denominator of my second rational expression. Now that I've done that, I can factor and solve. So I want you guys to pause this video and factor the numerators and denominators of both of these rational expressions. Okay, so go ahead and do that. Okay, so hopefully you've done that. When you factor, this is what you'll get. You'll get a, of course, stays in the numerator of your first rational expression. There's nothing we can pull out of the denominator here, so our first rational expression stays actually exactly the same. Then I'm going to bring down my multiplication sign, which just got a little bit covered up over here. Here it is. All right, when I factor the numerator of my second rational expression, I see 3 terms, so I would use AC method. When you use the AC method, it should factor as 2a plus 3 times a plus 10. All right, and then when I look at the denominator of my second rational expression, I see that I can pull out an overall GCF first. So I can pull out an A because look, they all have A's. Okay, so that's my first factor that I'm going to pull out. Once I do that, I'm left with a 3-term polynomial. So then I'm going to use the AC method. All right, I'm left with a squared plus 6a minus 40. That factors as a plus 10 times a minus 4. And again, if you're not sure where I'm getting these factorizations from, you guys pause the video and factor these yourself. At this point, I expect you to be able to do that. So I'm not going to go into the math behind it. And now I can do the fun part. I can go all willy-nilly and just cross out factors of 1. So A and A, goodbye. Right? Anything you see that's the same in the numerator and denominator just cancels to 1. 2A plus 3, 2A plus 3, see ya. And then, of course, there's A plus 10 and A plus 10. Peace out. So now I need to see what I'm left with. And here's the thing, you guys. I am literally left with nothing in the numerator, right? I canceled all of these factors in the numerator out. That doesn't mean you put a 0 there. That means everything canceled out to 1. So a 1 is now going to go in my numerator. In my denominator, I was left with an A minus 4. So the answer to this is 1 over A minus 4, which I actually think I have written a lot more nicely here. Yeah, 1 over A minus 4. All right, so be careful. If you're left with nothing in the numerator or nothing in the denominator, you don't put a 0 there, and you don't flip anything to where it shouldn't belong. Like I wouldn't take this A minus 4 and put it in the numerator. It has to stay in the denominator. I'm just left with a 1 up there. All those factors of 1 canceled out to give us 1 in the numerator. So that's why I have this 1 here. Okay, and the A minus 4 has to stay in the denominator. That's where it is. It doesn't magically get to go to the numerator. So here's one for you guys to try on your own. Remember, first change this division to a multiplication. And this, I put this here because it usually really throws students off, the fact that this is just a polynomial. It doesn't look like a rational expression. Well, you guys, you can always make a rational expression by putting a 1 there. All right, that's still x squared plus 4x minus 45. X squared plus 4x minus 45 over 1 is still x squared plus 4x minus 45. So you really have this invisible 1 in the denominator just to get you started. All right, good luck and have fun. Post any questions in the discussions forum. Bye.